Hey everybody, welcome back to another edition in geometry. Mr. Anderson here with you, your fearless leader. Today we're in section 3 of chapter 8. So 8.3, we're going to talk about some special right triangles. So still more with right triangles, but just some special cases that we're going to talk about today. So our objectives, we're going to use the properties of 45, 45, 90 triangle. And then also another special right triangle is the 30, 60, 90 triangle. Okay, so those are the different triangles that we're going to talk about today. Let's start with the 45, 45, 90. Okay, so here's an example of 45, 45, 90. Kind of our starting point here. I don't know how well I can do this. We're starting from a square, so I'm going to kind of draw the rest of the square in here. It's like we had a square, and we cut it. We made a diagonal here, okay, from one corner to the other. And so if you remember about squares, first of all, you remember all their sides are the same length. Okay, so we know that in our triangle, what's left here, when we cut the square in half, we know that this and that are the same length, right, because it came from a square originally. Remember also in a square, all the angles are 90 degrees. Okay, so this is marked as 90. This is also 90, that's 90, that's 90. Well, when we draw this diagonal here, it cuts that 90-degree angle in half, and so we get 45 degrees here and 45 here. So this is where we came from. We took a square, we cut it in half. And so what we're going to do here is in our triangle, we're going to call the length of this, remember this is a leg, right, on the 90-degree angle here, the two sides that make up the 90 degrees, remember those are the legs, so we'll say L for leg. For some reason they like to use the cursive L. So L for leg, and then in our triangle again, this angle, this side that goes across here, this is the hypotenuse, so we'll say that that's H for hypotenuse. Okay, and so being that it is a right triangle, we can use the Pythagorean theorem. Remember what we had just done? A squared plus B squared equals C squared, right? So we're going to do that, but we're going to use, since this is a certain specific kind of triangle, right triangle, we're going to use the L's and the H's. Okay, since we know these are both L and L, that's your A and your B. Those are the legs, the A and the B. So I'm going to go over here, I'm going to put this in, I'm going to say L squared plus L squared equals the hypotenuse, or C. So we'll call that H squared here. Okay, well, what's L squared plus L squared? Well, I have one L squared. I add another L squared to it. I have two L squareds. And what I'm trying to do here is I'm going to solve this for H to find out what H would equal. And so what's the opposite of squaring something? Taking the square root. So we'll take the square root of both sides, which leaves me with just H. The square cancels the square root. And then over here, remember how we could split up when we're simplifying a radical? We could split up and do these separately. So I've got square root of 2 times the square root of L squared. And then just like what happened here with the square root of H squared, the square root of L squared, that can cancel out and leave me with just an L. So what I have left here is I have just that L. That, the square root of 2, I couldn't simplify. And so I've got this. This is a little formula here that's going to help you in these situations. Now, I just did the Pythagorean theorem just like we did, but all those steps I had to go through. If I can just remember this formula here, it's going to be a lot easier. So the H, or the hypotenuse here, would just be, I'm going to, if I can find out where my cursor is, this would be just L times the square root of 2. So if you have a 45, 45, 90 triangle, you know the length of one side is the same as the length of the other side, and the length of the hypotenuse is just going to be that same length times the square root of 2. Let's look at the official thing here. And so again, here's kind of the official drawing. Notice here's our 45, 45, 90. L, the leg is the same, both are the same. And as you see, the hypotenuse is just going to be the length of whatever this leg is times the square root of 2. So kind of a pretty simple pattern to remember there. Just leg, and then the leg times the square root of 2 for the hypotenuse. So let's just do a couple examples here. All right, so we look on here, we say, hey, here's 45 degrees. That means This is also 45, so this is a 45, 45, 90 triangle. I can use my little pattern. And so, again, remember that just with the hypotenuse was the leg times the square root of 2, if you want to think of that. So you say, well, which one is which? Here's the 90-degree angle. That means 9 is a leg. That means this would also be 9, right? And this would be, what, the leg times the square root of 2, which would just be, if we know what the leg is, just plug that in. Oh, the hypotenuse is 9 square root of 2. So this would be just 9 square root of 2. So those are the missing lengths there. So 9 and 9, and then 9 square root of 2. Pretty simple, right? Whatever you have for the leg, just multiply it times the square root of 2 to get the hypotenuse. How about another one? Ooh, this one looks a little trickier, but think about it. We're just going to do the same. Oh, as a matter of fact, there is something. Oh, no. Here's what we can do. I was thinking, yeah, they didn't tell us what the degrees are here. But you know what? Because we've been told that this is 6 square root of 2 and this is 6 square root of 2, since those two are exactly the same, then we know by default that these would be 45 degrees here. So they didn't give us the degrees, but we know that these are the same length, so this has to be, and this is 90, so this has to be a 45, 45, 90 triangle. All right, so remember our pattern. To find the hypotenuse here, which is x, we just take one of these lengths of the leg and multiply it times the square root of 2, right? So in other words, we're going to say x would have to equal the leg, which is 6 square root of 2, and we'll have to multiply that by the square root of 2. So you take, so this is like, this was our leg length here, leg times square root of 2. All right, so when we multiply this together, general rule of thumb, I think we've talked about this before, if there are numbers outside the square root, you can multiply them together. If there are numbers inside the square root, you can multiply them together. So since we have a square root of 2 and a square root of 2, we can multiply those together. And so what I'm going to have here is 6 times 2 times 2 is 4, so times the square root of 4. And what's the square root of 4? Just 2. So it's a date, right? 2 and 2, it's a date. They get to come out of the house as a regular 2, which then would just be 6 times 2. Now they're all outside the house, and we can multiply them together to be 12. So x would be 12 in this case. Okay? All right, how about this now? We're still dealing with 45, 45 triangle, 45, 45, 90. This time we know what the hypotenuse is. We're trying to find the length of the leg. Now these are both the same, A and A, so they're both the same. But let me start with this. Remember how we've done this before? A, remember we called this L, and this was L square root of 2. Okay, so that's the pattern that we're looking at. So if you look at this, say if 8 is like the L square root of 2, what did I have to get from L square root of 2 to get back to L? Well, one way that you can look at it is you say, hey, you know what? Since I multiplied L times the square root of 2 to get to this, I could just divide by the square root of 2, right? So I could say, well, I'm going to do the same thing with the 8 then. So I could start out and I could just say, well, 8, if I take 8 and I divide by the square root of 2, that should get me back to whatever this is, right? Because if I start with L square root of 2 and then I divide by the square root of 2, what happens? Cancels those out and I get back to L, right? So I do the 8 divided by square root of 2. So you say, okay. Well, that's great. Well, here's the thing. I didn't talk about this in one of our earlier lessons when we talked about simplifying radicals. This is another thing that you have to do when you're simplifying radicals. We do not like to have a square root in the bottom of a fraction, okay? So this is something that we don't want to leave our answer like this. We have to simplify this a little further. This is what's called rationalizing the denominator. It's a lot of writing there. Okay, that's 2 words. Rationalizing the denominator. Okay, so whenever we have the square root on the bottom of a fraction, we need to get rid of it, okay? How we do that is this. Whatever, remember, we can multiply by anything as long as it's the same on the top and the bottom. That's like simplifying a fraction is how you do it. So since I want to get rid of the square root of 2, remember in our earlier example there, when we had a square root of 2 times square root of 2 equaled 2, hey, there was no more radical anymore. So I'm going to multiply this by square root of 2 on the bottom. But if I do it on the bottom, I have to do it on the top as well. So now what I have is 8 square root of 2 over square root of 2 times square root of 2 is just 2. And just like the rule I told you a second ago that if anything's under the radical, you can multiply it together. And if it's outside the radical, you can multiply it. Same thing applies to division. In this case, the 8 and the 2, this 2 down here, are outside, and so we can divide them. And so 8 divided by 2 is 4, so this would end up just being 4 times the square root of 2. Okay? So that's one way that you can think about it. If you know the hypotenuse, just divide by the square root of 2, you might have to rationalize the denominator here. The other way that you can think about it too, which gets you in the same place, is just remember our formula here that h equaled L times the square root of 2, and then you could just plug 8 in for h. And then what happens? Oh, to solve this equation, I divide by the square root of 2, and if you notice, that's exactly what we just did up here to start with. 8 divided by the square root of 2, and then you go through all that same stuff. Okay? So if you know the leg, multiply it by the square root of 2 to get the hypotenuse. If you know the hypotenuse, divide it by the square root of 2 to get the leg. All right, so we'll do one more just to kind of reinforce this here. You notice here on this one, we've got 6. That's the hypotenuse. This time B is the legs. So remember, all I'm going to do is I'm going to say, well, if I know the hypotenuse, to get to that, I had to take this times the square root of 2. So I'm just going to take 6 and divide by the square root of 2. But, oh, there's a square root in the denominator. I'm going to have to clean that up. So I'm going to just multiply by the square root of 2 over square root of 2. So this equals 6 square root of 2 over 2. And then 6 divided by 2 is 3. So our answer there would just be 3 square root of 2. Okay? Hopefully you're seeing that a little bit more easily. 30, 60, 90 triangles. Okay, so here's the other thing that we're going to look at today. The 30, 60, 90 are kind of our starting point here. This triangle is an equilateral triangle. So this is kind of our starting point for the 30, 60, 90 is an equilateral triangle. Okay, so remember, if you have an equilateral triangle, remember all the angles are 60 degrees. So there's 60, 60, and then remember up here, this whole thing is 60. But we're going to draw this altitude here. Okay, so remember, first of all, one thing about when we draw an altitude, it goes from this side straight up to the vertex at a 90-degree angle, so that's going to be 90 there. And since this is an equilateral triangle, it actually splits the 60 into 2 equal parts, so 30 and 30. And so what you have here now was we started out with a big equilateral triangle. When we did this and drew the altitude, now look at just say this right half here. This is a 30, 60, 90 triangle. Okay? And so if you remember, so not only in a equilateral triangle are all the angles 60 degrees, but all the sides are congruent. They're all the same length, right? And so if you notice over here on this side, it was written that this was 2x. And we're writing it that way because it makes the rest of it work better here. But if we call that one 2x, this would have to be 2x. And then this side would have to be 2x, which means since this splits it exactly in half, basically, you know, there's your 2x. Okay, so 2x, 2x, and 2x. But we're just going to look at this half over here, which means it's not 2x, since I'm just kind of discounting all this part here. It's just x. X, 2x, and then a. We're going to have to figure out what a is, okay? And so let's just work through this. Remember Pythagorean theorem? A squared plus b squared equals c squared. In this case, remember the a and the b are the two sides that make up the 90, so that would be a and x. So we're going to go a squared plus x squared would have to equal 2x squared. Okay, so we're going to solve for the a here. So that means a squared plus x squared equals 2 squared is 4, x squared is x squared. Let's move this x squared over here, so I do that by subtracting x squared. So now a squared equals 3x squared. I had 4 of them, and I subtracted 1, so now I have 3. And what's the opposite of squaring? Taking the square root. So now I just have a equals this, the square root of 3x squared. Remember again, to simplify, I'm just going to write the square root of 3 separate from the square root of x squared. What's the square root of x squared? That just comes out to be x. The square root cancels the square. And so in this case, here's kind of another little formula that a, or this other side here, is going to be x times the square root of 3. So that's what the missing length is here. We know this side's x. We know that's got to be 2x, and this is x squared of 3. So I just kind of showed you how they came about that. So again, here's kind of the official thing that shows you the relationship. So in the 30, 60, 90 triangle, they're calling the short side, this is the short side, which is straight across from 30. Okay, so if you look at 30, straight across from 30, that's S. That's your short side, S. The side, the other side, from the original, remember the original triangle is 2S, so that's your hypotenuse here. And then the altitude, or the other leg, is S times the square root of 3. So it all starts back from this side. Whatever the short side is, whatever S is, you just go times 2 to get the hypotenuse, and then times square root of 3 to get the other leg. Okay, let's look at a few examples here. All right, so in this case, first of all, let's figure out where do we start from? Where's the short side that we start from? So look at the degrees here. Here's 90, here's 30. Okay, so 30, remember, is smaller. Here's 60. Okay, so 30, 60. So remember, the short side is whatever side is straight across from 30. So this is the short side. This is like our S here. Okay, so this is our S. And then now the question is, here's the hardest thing that for people to remember. They always forget this. They get these mixed up. If I'm starting from S, which one of these goes 2 times S? Okay, it's the hypotenuse. Okay, so here's 90 degrees. Hypotenuse is the Y. So this is going to be 2S. I was kind of thinking about this. I don't know. I've never used this before, but I was trying to think, how could I remember this? The hypotenuse. Yeah, see, I don't know exactly how I want to go. Hypotenuse, like you think about if somebody has a hype man, if you're hyping something up, what happens? You're like kind of exaggerating, like, oh, this is great. This is like 2 times better than everything, right? So maybe that'll help you think, hey, you know what? From whatever S was, then the hypotenuse is hyping that up, so where it's double. It's doubly good. It's really good, okay? So the hypotenuse is like your hype man, okay? So whatever S is, you go 2 times S, and then by default, then the other leg would be what? Just S times the square root of 3. The other thing that sometimes people forget about, I'll give you another little trick here, or hint. When you look at the 30, 60, 90 and the 45, 45, 90, one of those, in the 45, 45, 90 triangle, we had a square root of 2. And here we have a square root of 3. Sometimes people get the square root of 2 and square root of 3 mixed up. Since this is square root of 3, here's how I think of it, is the square root of 3 always goes with the one that has a 3 in the degrees. The 30-degree angle is that's where you're going to have a square root of 3 in that triangle. Okay, notice in the 45, 45, 90 triangle, there are no 3's in that. So you use the square root of 2. That may or may not help, I don't know. Anyway, let's solve the problem. So now we know which ones go where. So let's start with the 2s. Okay, so if we're starting from s, 2s is the hypotenuse. So if we're starting from 4 square root of 3 over 3, if I just go, wow, that's crazy. If I just go times 2, I'm going to go times 2 because that's s to 2s is times 2. What does that give me? 2 times 4 is 8 square root of 3 over 3. So that's the y. I should have written that in there. That's y. I just went times 2. Remember, you can just multiply the stuff that's outside. So we can go the 2 times the 4 to give you 8. All right, and then for x then, we've got 4 square root of 3 over 3. We're going to go times the square root of 3. So times the square root of 3 over 1. So now we can multiply what's under the square root. So we have 4 times what? Square root of 3 times square root of 3 is 3. 4 times 3 is 12. Over 3 is 4. So the x would be 4 there. Okay, hopefully it's making a little sense. Let's look at another one. This time, we don't know the s that we're starting with. Okay, so remember, let's look at where everything is. The 30 degrees means straight across from that. This is your s here. Okay, so this is the s side. All right, which one is 2s? Which one's going to really hype that up? The 2s is the hypotenuse, which is this one. This is your 2s, which means this one here is the s times square root of 3. Okay, so but we're starting with this time. So now what I want to do first is get back to find out what s is. Well, if 4 square root of 3 is s square root of 3, you might be able to kind of, because the square root of 3's are the same here, you might go, oh, well, hey, 4 has to be, s has to be 4. And you're correct. And so how we, basically, again, how we did that was we would just take that 4 square root of 3 to get back to that. You just divide by square root of 3. And then when they cancel, we just have 4 there. And that's AB, or your S. Okay, so this is 4. Now from that, then you just go, oh, well, what's this one going to be here? It's just going to be 2 times 4, or 8. So BC is just 4 times 2. I don't know why did I put a box around that one? 8. There we go. Okay, so whatever, in the first case we knew what S was, then we just double it and go times square root of 3. This time we know what this leg is, and so I have to divide by square root of 3 to get back to the S, and then I can double this one, okay? So I got 4 and 8 on that one. I think I got one more here. Now in this one, okay, we know side BC. Well, again, let's put everything in place. The square root of 30 degrees straight across from that. This is the S. Okay, what's double that? Remember, that's the hype. That's the hype. Oh, it's great. So the hypotenuse is this one. So this is 2S, which means this has to be S square root of 3 down here. Okay, that's the way they fit together. So we're starting with 2S here. Well, that's 2 times S. So if I have 2 times S, what do I have to do to get back to S? Divide by 2, right? So I have to do 16 square root of 3 divided by 2 this time to divide by 2 to get rid of that 2 to get back to this. The stuff outside we can divide to B. So that's AB. 8 square root of 3. So now that I know that this is 8 square root of 3, then now I'm going to go, well, if that's what S is, now I just plug that in for this S here and go times square root of 3. And so that means I'm just going to take 8 square root of 3 times the square root of 3. Square root of 3 times square root of 3 is just regular 3. It's a date. 8 times 3 then would be 24. And that's AC. Okay, hopefully we're getting a hang of this here. So in summary, here's the two patterns. You notice on the left here, 45, 45, 90. And the pattern beat, you have leg and leg are the same, and then the hypotenuse is leg times square root of 2. And on the 30, 60, 90 triangle, you notice straight across from the 30 is your S. The hypotenuse is 2S. Again, it's hyping it up. And then the other leg would be S times square root of 3. Okay, so there's our summary on those two triangles. Appreciate you being here. For the special right triangles, 30, 60, 90, and 45, 45, 90. This is Mr. Anderson saying so long. We'll see you next time on The Price is Right.